When I'm graphing in standard form, I have two choices. I can either take the standard form and complete the square to change it into vertex form, or I can use the formula negative b over 2a. I'll show you both methods. The first one is, if I want to change this into vertex form, I first need to factor the leading coefficient of -1 out of the quadratic term and also the linear term. I leave a space and I do not factor it out of the constant that's at the end. In order to complete the square, I do not go back to the old 8. I go and look at the new -8. I take half of -8 and square it, which gives me -4, and when I square that, I get a positive 16. Before I put the opposite outside, I need to multiply 16 with the -1 in front, and I will end up with -16. So the opposite of that number is positive 16. I factor the x squared minus 8x plus 16. You can either say what adds to be -8 and multiplies to be 16, or you can go to the -8 and take half of it and square that quantity and combine like terms outside, and you have your vertex form. The other option is to go back to the original problem and do -b over 2a. So I have -8 over 2 times -1, which gives me 4. And I can substitute 4 in, but then you need to do this in your head without a calculator. This will give me -16 plus 32 minus 14. -16 plus 32 is 16, minus 14 is 2. In any case, your vertex should come out to be 4, 2, which is what it did over here as well. So I can go write down that my vertex is 4, 2, and I can plot the vertex on the graph. The pattern to graph the rest of the parabola is 1, 1, 2, 4, 3, 9, because 1 squared is 1, 2 squared is 4, 3 squared is 9, and we're working with quadratics. But be careful, the leading coefficient is -1, so instead of going up 1, 4, and 9 spaces, we're going to go down 1, down 4, and down 9 spaces. You can connect the parabola, make it look like a U shape. When I go down to the bottom, the axis of symmetry is a vertical line, so it's always x equals, and it goes through the vertex, so the x-coordinate is 4. I can't see the y-intercept on the graph, but I know in a y-intercept the x-coordinate is 0. So if I go substitute 0 into my equation up here, I get 0 plus 0 minus 14, and I will end up with the constant as my y-intercept. Since the graph is reflected and opens down, the maximum is at the top, or the vertex is at the top, making it have a maximum for the graph.